In today's episode,
we have 100K device available directly.
Breaking Labs, a CXLabs story.
200K square feet labs available.
Our guest tries to control thousands of virtual machines
13 terahertz.
and thousands of wild, stubborn engineers.
100 terabyte of RAM.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers.
Hello and welcome to episode 22 of the Cisco Tech Stories podcast. Approaching now almost 2 years already. Time flies. We're your hosts, Tristan and Nico from Cisco EMEA. Hello, Nico.
Hello, Tristan. Today, join us as we explore the fascinating world of Cisco Tech Lab, where challenges are met with ingenuity and customer satisfaction is the ultimate goal. We'll delve into the inner workings of the lab, uncovering the processes that drive innovation and learning how CXLabs shapes the future of customer experience. Whether you're a tech enthusiast or a professional looking to gain insights into industry-leading practices, this episode will dive into the mechanics of one of the biggest networking labs of the continent. So grab your headphones, settle in, and get ready for a great conversation with Regis Baudin, technical leader in CXLabs Brussels, right here on Cisco Tech Story. And today we have Regis. Hello, Regis.
Hi, Nico. Hi, Tristan.
Can you introduce yourself for a little bit? Who are you?
This is Regis Baudin. Actually, I'm working at Cisco Brussels, Belgium. And now since 18 years, yes, I joined in 2007, 2008. That's a long time ago. And working in the CXLabs since I joined Cisco. And I'm today a technical leader for the CXLabs lab infrastructure and more data center and more especially also in virtualization. That's great technology that we find everywhere today.
Yeah, it seems like you're separate from the tech team, right? There's all the tech technology teams, and then there's also the lab team, which had a different name before, but now it's called CXLabs, right?
Okay, so actually CXLabs, we are behind the scene. I would say like this because, as you know, we have the tech engineer who are supporting the Cisco customer. So they are in contact with the customer all the time. And if the customer has a device from Cisco, which is isolated, and we know that there is some questioning about this device, the tech engineer needs something in a safe environment where where the device is completely isolated and where it can connect and run some commands or run some configs. And that's where the CXLabs is very important, is that we provide to the tech engineer a bunch of devices available where they can connect and they can execute some tests.
And Regis, maybe you can give us a scale, like how big is the lab and how many labs do we have?
Yeah, so we have 4 main labs, which are located. So actually, we have 2 main labs. We are 24 hours. So we have RTP in US and we have in Bangalore in India. So those 2 labs are 24 hours. And then we have smaller lab, for example, in Europe, in Australia, in Sydney. Those labs are smaller, but you know what is small? I mean, it's quite big for us, right? So it means as well that in Bangalore and the RTP, those labs are really huge. So in total, we have around 200K square feet labs available. So this area, in this area, we have racks where we put so many devices. So I would say that. So a more recent number is we have 100K device available directly. So it means that you can connect to those devices directly right now. If you need it for a customer tech case, you can connect to them.
100K. And what type of devices does that take into account?
It's okay. So it means all the devices. So all the devices supported by Cisco. It means it can be UCS server, firepower, it can be a Catalyst. It's the access point, the wireless controller. It can be anything, and all, of course, those are virtual appliances that now we have. But that's an additional number to those 100K. So we have also this virtual infrastructure cluster where we need to run those virtual machines. Those virtual machines contains the virtual appliance from Cisco.
Mm-hmm. And how big is that virtual cluster, the one that you manage in Brussels?
Oh, in Brussels, so we have around 100 hosts. So we are working mainly with UCS server. And so at the moment, we are running 10K virtual machine. And it's a lot, right? We are they are not all power on, of course. So it means that we ask the user to power off the VMs, and we have also some automation behind. In terms of virtual machine, it's very difficult because the engineer or even people today think, okay, it's virtual, so it's unlimited. I can create 2, 3, 4, or even if I create one virtual machine, why I will just restrict to 2 gig or 1 CPU? I have in the drop down all the CPU, so I can go to 16 CPU, for example, and 32 gig. But they don't think that behind there is those limitation, of course, that we have. So that's in terms of numbers, this is what I can tell. We have also, I can say, around 13 terahertz. Okay, that's a lot, or 100 terabyte of RAM. So this is those numbers that we have in the cluster in Brussels. Okay, I'm talking about Brussels only. So I told you just before, it's a small lab, right? So think about the big lab.
And in Brussels, how many rack space do we have? Like number of racks?
So in Brussels, we have 2 floors and 200 racks per floor. So we have 400 racks. And I can tell you they are almost full populated. Yes.
Yeah, I know that. Yeah. So 400 racks is a small lab. There you go.
Yeah, exactly. So, yeah, you realize.
Yeah.
So it's already obvious from what you said what are the responsibility of the CXLab team, because first of all, if we're just talking about hardware, it's obvious that engineers, an engineer from a specific technology would be able to maintain some of his or her devices, but maintaining the whole lab infrastructure is so big that, we obviously need a separate team for that. But then you mentioned also virtual machines, right? Managing so many virtual machines, it would be impossible if every technology team was having their own UCS servers, having their own virtual machines. It would be clear that nothing would work with each other, right? We would have loops everywhere, we would have problems everywhere. So it's obvious we need a lab team to maintain the rules, maintain security, maintain all of that.
That's true. And back in 2009, we started with just one, server where we installed ES6 4.0, I think it was. And we started to play a little bit with that server and realize, yeah, it's nice. But I think in parallel also, the tech engineer, as you said, Nico, was also discovering this part of virtualization and start to create their own server. And the mess start in our lab. Exactly. We found a lot of server everywhere in the lab with a small ES6 installed. And then I'm
guilty. And it was not only ESX, we were trying other virtualization platforms and trying a lot of things, and it was not nice.
Yeah. And we realized also that people were using those small clusters, but starting at the point when a virtual machine is destroyed, and this virtual machine was important to the engineer, that we come to a situation where we realize that those clusters were really important. So those small projects that start team by team in the end was really important so just some user didn't realize that they were running their virtual machine on a small cluster. And one day their virtual machine disappeared, and all the work, what they did disappear. So we created a big cluster where we put all the virtual machine from all the tech team, and this cluster is shared. It's a save of resource, it's a save of work, it's a save of energy, of course, because we have everything in one place, and we have the key word is life cycle. So we like this life cycle word for the virtual machine. Virtual machine is created, used, and destroyed. And if it's maybe need later, it can be saved as a template. So this life cycle is very important for us, and it saves us a lot of resource as well.
And the great thing is that you guys built a huge amount of tools around that to automate this. So whenever we, as tech engineer, require a virtual machine, we don't need to ask you. We can do that we can do everything on our own. We can just go on tool, say, I want a Linux VM, a Windows VM, Catalyst 8KV, whatever. And boom, 5 minutes later, we've got everything ready. And you had to do nothing. Everything is automated, right? So how much have you guys spent on those tools, like in matter of time and effort there to have that running for us?
That's a great point. Today, when you release a tool, you need to open the API. And that's exactly what we try to do with the tool that we're offering internally, is that we have this tool which managing the life cycle, but offer this API to all the users. So it means that if you have a recurrent task that you do, you can automate it, exactly. And you can, for example, we have the security team who can, in one click, create a VMs, restore a backup, and make it available. So that they can do something in parallel, and that's the the win point. So we are really happy that our users are using the API because it's there for that purpose. Exactly.
And so if I can relate to the past, right? The people opening, tech engineer opening a lab case was typically when there's a big topology, right? So if I need just my technology device, I can maybe even do it myself in the lab. But if I'm going to need to plug my access point in a specific manner with specific SFP to specific switch models, with a specific router simulating a branch office, blah, 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 I better use the lab team because, first, I don't know where everything is stored. And then if I start to steal devices that are booked, it's not going to be fine. But now all these lab cases turn into virtual machines, right? So you're automating that part because, in the amount of hardware, you already had automation tools in the past to just plug stuff together, right? It was not only physically moving boxes and plugging them together, but now with automation with the VMs, you have to create pods and ready-made solutions, right? Otherwise, you would not be able to scale with the demand because people are asking for crazy stuff, crazy pods, crazy setups. They're expecting it right now, right?
Yes, true. And we can anticipate a little bit. So on that point, what we offer in the lab, and we are working with a tech engineer on every day, we are building topology which are there and ready. And those topology are, the more famous one that we sell when we sell the Cisco product. So we are ready with those topology. Or what we can do as well is to connect, for example, layer 1 PC to sniff the traffic. If you need to capture the traffic, and we know that your team do that on daily basis, we can already anticipate a little bit and create some pods. We call that pods, where you can reserve that pod and you have like an access point, a wireless controller to layer 1 PC, which are already connected, and you can capture the traffic. And then what the engineer can do is to regenerate the traffic. So we know that we need to generate traffic. So you have a topology and your customers say, okay, I have 1,000 users using this topology, and you need to regenerate those traffic. We cannot do that in the lab, right? We don't have those 1,000 users. So what you can do is, let's say, those TCP replay that you can use, but we have also other products in the lab that we are using to generate sometimes 100 gig of traffic in a topology. And what we try to do, and what our users try to do actually, is to break this topology, because we try to push the device to the 100% over the capacity can to just test it. And those tools we have them in the lab, and sometimes it's part of a pod. Yeah.
Yeah, and that's crazy, man. I've been in tech for the longest part of my career in Cisco, and the lab has been one of the most valuable tools that we have. And you guys have been doing so much work in the background for us to work on customer issues. It's crazy. Like, I can tell you that without those tools like traffic generators, the VM, and your availability just to build anything that we need, like we are asking you, hey, Regis and the team, can you guys build me this setup? And like a few minutes later, most of the time I've got my setup ready. It's just crazy. And the thing that we can reproduce thanks to you, it's unbelievable. So
That's
you
awesome.
guys enabled, you guys enabled so much success stories in Cisco. I think it's underestimated for sure.
Thank you for that. And we try to improve every day. You know, we have those automation coming into the business, those AI. We try to integrate that in the lab as well. So today we have in the lab, a part of the lab, we can do layer 1 connectivity remotely. So you are going to tell me, but how can you do that remotely? You need to be on site. But actually, with the NCS from Cisco, we can create those X-Connect MPLS tunnel that will interconnect two devices, and all the traffic over layer 1 will be just, going from one point to the other point, and it's like a physical connection. And this is something that we use sometimes. If someone is remote, he can interconnect two devices directly as it's a physical connection. So that's great.
As if they're back-to-back connected. Yeah, that's crazy. And you might think, look, the lab is 400 racks, right? So sometimes you need a device that's on floor 1, rack number 1, and the other device is on floor 2, rack number 199. So they're the totally opposite of the lab. So how do you guys manage to connect all of that so easily?
Yeah, that's sometimes crazy. And we know we have those physical restrictions, definitely. So on top of the rack, we have patches, and we have those patches they go to a central street. We call that the spider street because you see cables everywhere. And you know what? We have to clean that street because after 1 month, you realize how many cables we can plug, and it goes from... It's crazy. So we have to clean those cables every month. But to connect one device on floor 0 to floor -1, we definitely have patches. So on top of the rack, then we have a central street that we connect to the -1, and then from there we go to the other device. That's how we do. But yeah, that's a point as well that is part of our daily job, is to clean those cables. We have so much cables and fibers, because I'm thinking about fibers. For that, we like the wireless team, because they don't create this huge amount of cables. We don't have to clean the wireless team area. It's good.
And because I was in the cable team before, I feel a bit offended, because I think that some of your comments are meant directly to me then. I was personally responsible for a lot of the mess in the lab. I'm sorry. It's something that people don't realize, that when you see pictures of data centers from big companies, you see that it's all clean. And the patch panels are nice. The cables are tied with zip ties and all that stuff. It's not the case here, right? Because the lab changes all the time. So you build a setup, and next week it's going to be gone, and you're going to need another setup, right? So you don't spend time to do too much cable management, right?
Mm-hmm.
I have to say, in the past, it was not always like this, Tristan, because when I started, we had a lot of access, and we were doing a lot of the cabling ourselves, and that was a bad idea. And Regis' team actually told us, guys, your area is a mess. Like, let us take it over and stop touching it. And it's for the best. Like, I see people sometimes making fun of dirty data center with lots of cables, and I'm like, I've seen worse. I've done worse. I'm responsible for worse than this. And now I can understand the value of clean cable management. So people don't realize.
It was you. Okay. All right. Yeah. Exactly. So we like that our tech engineer go to the lab because they can see the product, and it's very important for a tech engineer to see and to have hands-on. Right. We call that hands-on. So the tech engineer, they go to the lab, they can see the product, they can play with it, they can connect, they can remove the SFP, they can open the box, right? The lab is there for that. We have all the tools. That's really an area where you can test, you can open, you can break, you can reuse. But definitely we try to tell our user to keep clean the lab. It's not easy for them because they are in contact with the customer, and we understand that, and that's the most important. So what we like is the communication. So keep collaboration, and that's the key word as well, the collaboration between the CXLabs team and the tech engineer.
Do you have a good story about troubleshooting problems? Because that's what we like here. There must be a lot of problems. I mean, for sure, on a daily basis, it's small problems. Like I cannot reach my setup, but there has to be bigger problems.
We have very easy troubleshooting. Like when we provide a device to an engineer, you have to know that in the lab we have power management, and this power management is awesome. So it means that all the devices are power off, and as soon as a user reserve a device, this device is power on. So we save energy, we save cost, and so on. So this is really important for us. And you have to know as well that this is so smart that it power on the device during the shift of the engineer. So when the engineer will work, as soon as the shift is done, it goes and is power off. And unfortunately, sometimes, and most of the time, the engineer, they work offline after the shift. And they try to connect to the device, and of course, the device is off. So they contact us and say, look, I lost access to the device. And we have to tell them most of the time is because just the device is off. So it's very easy to troubleshoot, right? That's a common one. But no, more seriously, troubleshooting is in the lab is also on the daily basis. So, we have a lot of connection from devices to the lab. And sometimes we see loops, we see bridging. For example, let's say that we have a firepower, and on the firepower, this security appliance, we can install an ASA or FTD. Let's say that you install the FTD, and then you put that FTD in transparent mode. So it means that this FTD will just act like a layer 1 and just let the traffic goes through without any spanning tree and so on. And now, let's say that we have 4 connections on this firepower, or even 2 connections. It causes a mess in our lab because it starts to forward all the traffic that it gets, and we see latency in the lab. So then we start from our gateway to see from where the traffic is coming. So we just check on the interface the input rate. So we do like a show interface, and we just filter with the include command, where we say show interface pipe include input packet, and we see from where the packets are coming. And then we just go down in the tree and see from where the traffic is coming. And then when we have isolated the device, I won't explain more. No, I'm kidding. I will contact the engineer and ask to not do this again.
It's funny because when it happens to us, typically for us, it's VLAN bridging. We have devices, you can put an access point in client mode, and it's easy to plug 2 things together that just don't do spanning tree and create a loop. We discover, the lab, it's only our subnet that is slow, so it must be coming from our subnet, and we kind of do the same technique. And once we find the device, it's like, okay, who put this there? No one raised their hand. Suddenly, this device showed up out of nowhere. Yeah, it's annoying.
True, and we have the same on the virtual machine. So as you said, you can just boot up a Windows and make a bridging between two interface. Or you have the virtual appliance from the firepower, so the FTD can be virtualized as well. So now think you have 10,000 of virtual machine, and you need to find the one which is generating the traffic. So we need to troubleshoot this Broadcom product, VMware Legacy. And yeah, it's not easy, I can tell you.
It matches the feedback. We interviewed Esther, who's a routing and switching CCA, and she said, "Oh yeah, spanning tree loops. It's always like the worst to troubleshoot." But I'm not even sure how we can have a functioning lab, because we have so many specific devices and appliances that can be virtualized in Cisco, and it's like, oh, you can spin this one with 3 interfaces. That interface is like a supposedly back-to-back high availability, but you're then supposed to plug it correctly to another virtual machine, but it's very easy to make a mistake there. And then you have another interface to do out-of-band management and another interface to do this. And even a good engineer might create loops, without paying attention. So
yeah, exactly. It's because we see behind the scene again. Huh? We see all of. We play daily with those virtual machine and devices, and not the tech engineer. So they use the lab really to reproduce something that they see on the customer side, but they have to take the decision. They make the decision to create a case with CXLabs, and place those devices on which it will work and test. But it's not for all the tech case, right? Of course it depends. But for us, when we see it, and of course for us it's kind of why you did that. Maybe you should know it, but actually it's not so. Yeah, sometimes it's quite weird.
How does that work? Like you have the lab, so the lab space. How do you guys receive devices? Do they come, boom, like one day a courier show at the door with a big pallet of devices and you need to install it? So how does that work, from device installation to power management, air conditioning and all that? How do you manage with all of that?
So that's a good point as well. So we so in collaboration with the tech engineer, we try to keep aware about the new product. And as soon as we know that the new product will come in, we order the product. And it depends on the price, of course. We can have one version of this product or 5 version of this product, and we order them just like a customer. So we are waiting the device. As soon as the device come in, we just unbox. We take the device, we put it in an inventory where we will follow the life cycle of the device, and then we put that device in the lab. So we rack it, we put a management IP address. So we will have access to the device via the management. We put a console. So it means that the tech engineer needs always the console, because that's the most important connection. And then we will most of the time put 2 additional physical connection to our lab network. So the user can play with VLANs, for example. And sometimes the engineer, they just pick up 2 devices in the lab and he just configure VLANs to isolate the traffic and interconnect those two devices, because it doesn't need to have layer 1 connectivity. I mean, it doesn't need to capture the traffic below that layer. So layer 2 is enough. And yes, and as soon as we have this, the life cycle of the device starts. And as soon as the device is end of support, we decommission the device and we just send it to the e-waste program.
And I actually, sometimes you even keep some older devices that are end of life in the lab. It's not always guaranteed, but sometimes it happens, and that's great, because once in a while you need to see how did that work on that device that's end of life for like 5 years, and by coincidence you can find one and still work on that and see, yeah, that actually changed this or that, and that's helpful to remember how it worked in the past,
Yeah. It's meant for us. We need to understand that it's very difficult to keep all devices because the space, again, it's not unlimited. We try in collaboration with the team to understand if we have to keep or not. But otherwise, it's really a matter of space again. Yes.
I have a question on the power you mentioned before in two previous questions. Do you have any number of the power used by the lab, like in megawatts, or I don't know how you measure it, and how the power saving, like how much you saved since you're powering off devices that are not actively used or powering at night, etc.?
We have 2K amps for the 2 floors available. So
2000
we are not,
amps.
we are not using them. I mean, that's the maximum. But we have to be very careful because we cannot use those 2K amps because we need redundancy. It means that if we need to, so we are working by phase. We have 3 phases, and we need to be sure that if we lose one phase, we have those, amounts of power going and shared between the 2 other phases. So we have to be very careful. It's a theoric amount, right? So in terms of power savings, we work every day to include a maximum of devices in the lab in this project. Why I'm telling that? Because think about virtual machine. It's not easy to go and monitor all the virtual machine utilization, because we need to play with the Broadcom product and understand how it works and make some automation product, some automation script to monitor the virtual machine, to shut down the virtual machine one by one. But also we don't need, we avoid to frustrate the owner of the virtual machine. Maybe they still need it, so we need to keep them on, right? So we try again to collaborate and to understand the real usage. Sometimes we need a power device to be powered on all the time because we are running traffic or packet capture that needs, 1 week, because let's say that the customer see the issue every three days. So we try to reproduce and we leave the topology in the lab power on during 3 days to see. So it really depends on the case, which is open with us.
Yeah, I remember that I had to work on a memory leak that was leaking 64 kilobytes of memory every day. And so 64 kilobytes, so very small amount. And I had to prove that if you leave the device powered on long enough, it would crash the box. And for customers, I mean, they have devices. I mean, you never power off a production device in customer network. They remain on for like 2 years, 3 years, how many? And they had devices that suddenly crashed, and we realized that they were up for like 3 years. And this was because of that small 64 kilobytes of memory leak every day. And I wanted to reproduce that in the lab. And of course, I mean, if you power off the device every night, that will ruin my test. So luckily, you guys were really cooperative. We can disable power management for some devices and leave them on. So I could leave them on for like 2 months in a row. And you could see the memory, like you could graph it, that it had a significant impact over those 2 months, because 64K kilobytes per day, you could see that on the graph. And that was cool. And those are the type of thing that, thanks to your flexibility and all the options that we have available in the lab, we can do. So sorry, I used a bit more electricity for those 2 months. But yeah, it was definitely worth it.
and those features are available in the tool that we have for that. But because yes, we have a tool which is managing all the devices in the lab, and from that tool that we build internally, we can do a lot. But I'm talking about that and utilization for the virtual machine, for example. What we do, because we cannot just live with that cluster all the time on and all of those virtual machines on, every quarter, in collaboration with the tech engineer, we shut down all the virtual machine. So the cluster is completely shut down. It means all the virtual machines are powered off. And we benefit of that maintenance window to patch the host, to upgrade, to maybe put in the cluster new resources, or maybe to decommission also old servers. And that's a good starting point to know if a virtual machine is used or not. And with that logic, we found really a new way to see if a virtual machine is used or not.
Yeah, indeed. Because, like you said, with 10K virtual machines, if you don't do any of those maintenance, you will end up with millions of virtual machines, and 99% of them will be not used anymore. And I'm guilty of that. It's so easy to say, let me just keep this machine for a while. I might need it later. And when you realize that it's been poured off for like 2 months and you did not even realize it, maybe it's because you don't actually need it and you can just delete it. So yeah.
Yeah, and talking about that, so I listened to one or multiple podcasts from you, and from the podcast 18 with Devon Aaron about Splunk, he said, I need a virtual machine with 64 vCPU. And those vCPU key word that he mentioned is very important, because those are really the resource that we are going to provide to the VMs, and we need to pay attention to that number. So when he say, I need for the Splunk a virtual machine of 64 vCPU, we need to be sure that we have those resources available for him, right? And shut down all the virtual machine one time per quarter, make available those vCPU for the user. Because so in the beginning of the podcast, we discussed about the RAM, the CPU, how many we have, but I didn't mention about the vCPU. This is a really important part of the virtualization. vCPU is really the key when you run a virtual machine. And actually on one host, you can oversubscribe vCPU. That's crazy. And that's where you see those virtual machines become to be slow and more slower and slower. So we need to be careful about this number. An anecdote that I have here about those virtualization back in 2014 with the UCS. So I was planning to do a quarter maintenance window, and at that time the UCS upgrade, the firmware upgrade and so on, was not automated like it is today. So you had to very respect step by step what was provided by Cisco. You had to upgrade first the CIMC, and then the fabric interconnect, and then the blades, but respect the ENIC, FNIC, and so on. And actually at 10 p.m. I was stuck, and the upgrade break, and I was alone, in the office. And actually, I did that a couple of times. Actually, it's something that we do every 2 times per year. But that time, it just break. I don't know. I didn't know the reason. So I opened a tag case. And with the follow of the sun model until 5 a.m., we troubleshoot first with US, and then the case was sent to Australia. And we continue to just work on that case. And the morning, at 8 a.m., the cluster needs to be ready for tech user. So it was really stressful. And at 5 a.m., we finally found the way how to restore it. And at 6 a.m., the day after, the cluster was up. Today, you don't have those issues anymore, because with your US Manager, the latest version that you have, and with Cisco Intersite, you go and you do the upgrade automatically. That's great. I love so much those new version of managing the UCS product. But yeah, that's just an anecdote that I have.
Yeah, and this is actually where you see how critical the lab is, because in many people's brain, a lab is not critical. It's a lab, right? But for us, a lab is the main tool that we deal with. If it's down, you will break so many customer updates. You will have so much delay in case resolution. It's really a high priority tool for us. We cannot live without the lab. It's crazy. Yeah. So.
Yes, and all the effort and all the project, and we try to improve more and more the life in the lab for our user. We have monitoring tools, so we are using Zabbix, for example, to monitor the traffic, the device in our backbone. We are using Splunk. So, this lab infrastructure. So I'm not talking about the end device that we have for testing, but the lab infrastructure, this network that provide connectivity is managed, for example, by Cisco Prime. So we have around 200 COM servers. Those COM servers provide access to the console of the devices. Those 200 COM servers, they need to be upgraded. We are not going to do one by one. We use Cisco Prime. You just go there, you create an inventory of all the COM server, you push the iOS, and then you order the upgrade, and it goes boom. So that's the kind of device that we are using. Those devices, product that we are using. Sorry.
So we use our own product for our own lab management. That's cool. And actually, we discover issues with that sometimes, right?
Mm-hmm.
You find bugs, you find things like the one you just had. We find issues sometimes ourselves with doing our own product. That's cool. Yeah. Maybe you can talk a little bit about how do you deal with the cooling and air conditioning and all that stuff.
This is something that we have to care about as well. A rack which is there since 15 years is not the rack that we need today. And in terms of space, in terms of power, in terms of cooling, let's just take an example. Let's say that you put just router and switches into one rack, and on the next rack you put all the UCS server into one rack. What do you think? Which rack will die first with the power? If you push at 100%, the UCS, they will just kill the power that we have in the rack. So we need to share the power between all the racks. This is something that we need to be careful. So we have technologies in the lab as well. So for example, in Brussels, we have this hot and cold ale technologies. So it means that all the hot flow will go into one ale, and then with the cooling, it goes cold into the cold ale. And this technologies is very awesome to manage the airflow more efficiently, and it enhances the energy savings. So that's what we are using in Brussels.
Yeah, and I love that. I remember when I joined 15 years ago, we had cooling issues in some part of the lab, and we had to run big air conditioning pipes through the lab to make it cool during summer. And now with those hot aisle, as you said, it's crazy. The lab is always so cold, like freezing cold, which is almost like an enjoyable place to go when it's hot in the summer. So you can just go there and chill a little bit to get some fresh air.
Yeah, that's true, and make more complex as well how you will architect. You make the architecture of the lab. Let's say that you have a device. Per device, you can choose how the flow will go. If the intake will be on the front or on the back. You can choose those when you order the Cisco product. And we care about this because we want the ports of the device to be accessible, to interconnect them easily. So those ports will be in the cold ale, and it will intake the flow, of course, from that side, which is the cold ale, and it will push the flow on the back in the hot ale. So this is exactly what you mentioned. Those technology are new. Before we came to a point where we had to install a big pipe in the lab. Thank you. I didn't want to mention it, but because you mentioned it, I have to. But yeah. That's exactly the point where we arrive, and suddenly we realize, okay, stop this. We need to refresh, and starting at that point. We just launched a big project to refresh the lab in Brussels.
we discussed before that we as engineers love to go in the lab because it's hands-on to devices, and we can build our own lab alone. Like I can plug my router to my switch to my firewall by myself in the lab. That was mostly true when we were going to the office every day, but after and during COVID and after COVID, going to the office thing is not really happening anymore. I mean, we still go sometimes, but not as much as before, which means that we need to rely much more on you guys to build labs for us. So how much did that impact you?
So you have to know that the lab in Brussels is used by other side than the local tech engineers. So it can be used by Krakow, it can be used by Lisbon, it can be used by Sofia. So it can be used by anyone. So it means as well that you can use it from home. Of course, it was already built to be accessible remotely. So the tool were already there. But with COVID, we had to accelerate a little bit the transition, right, to the way how to provide remote access, and this is where the pods were created. So we create more and more pods already built, and it's building those pods save us time for the future cases, right? Because the pods is just a small topology. It can be 2 devices or 3 devices, or it can be 20 devices as well. So those pods were created for the COVID and help us to anticipate a little bit the request from the engineer. We have also those, we just mentioned it before, the layer 1 connectivity that we can do remotely with the NCS, the Cisco NCS. This is something that where we put in place so the engineer can remotely create the connection between two devices. So we try to adapt. For the virtual machine, we also put in place, so I'm talking about virtual machine because we have layer 1 virtual machine. So we have, if you want to visualize, a UCS server on the back, we have 24 NICs, physical NICs. And on the device, we install virtual machine that will link to those NICs, and then we can sniff the traffic. So it avoids us to just have one, laptop to sniff the traffic from a device. We save space, we save energy again. But we have also wireless PC, because from the team for the wireless, they need those laptops with a wireless dongle, right? But here, what we created is exactly the same. We have a UCS with USB ports. We use USB hub, and then we connect the wireless key. So those are as well virtual machines. So when I'm talking about virtual machine, I'm taking those one into account as well. And we started to build more and more pods with those virtual machine as well, the layer 1 PC, the wireless PC connected directly to the device.
Yeah, so all of that allows you to have less physical operations in the lab, so we less need to have people moving stuff and cabling stuff, because all of that is like pre-provisioned, if you want, and ready for use. So like I can just go on the lab portal and say, search for this type of device. It will list me the pods. I can say book. I can access it right away, and you guys didn't have to move from your seat, which is great. And that's so much help. You just can't imagine. And the good thing is, if let's say a device is not available in Brussels because they're all in use, I can search the same labs in other sites, like in Bangalore, in RTP, in US, in wherever. And I can access those like if they were my local lab. And that's great. That makes an inventory of so many devices available to anyone. And it's just a giant playground. So for me, like I'm a geek. I love just playing around with devices. It's just an amazing tool.
So do you use a lot the other lab? By your experience in the past, did you?
I have to say I'm like a 95% user of Brussels Lab. Yeah, I mean, one of the reasons is it's closer physically, which means that it's slightly faster to do transfers, whatever. But I can find pretty much anything that I need. And the good thing is, if for whatever reason I need to do a change in the lab, I can go by myself, and I don't need to bother somebody in a different time zone. Which, I mean, they are there to help, and they will help if I ask. But if I can do it by myself, like you said, hands on the device is so important. So I love to do that. So yeah, mostly a user of Brussels Lab, but sometimes the device is not available, so I just need to bother a different site. Yeah.
And as a TAC, we have the follow the sun model. So it means that if you are working on the topology, it's not because it's the end of the day for us that we don't have to support, right? It's we can definitely have a topology which is built in Brussels, and if the team from Brussels is off, we can have someone remotely helping the TAC engineer to connect, or maybe to add something over layer 2 to the topology, and so on. This is something which is possible. But of course, we don't have in Brussels the 24-hour support, so we don't have someone who can interconnect with physical links, but we have this follow the sun, definitely. So if it's a CAPS, a P1, we can definitely reproduce. We can do 2 times the topology if it exists in Brussels, but it's definitely a high priority case. We can rebuild it in US. This is something that was done in the past.
Okay, so thanks, Regis, for being with us today. It was great having you. We learned a lot about the lab, your experience, all the virtual machines, and all the devices that we have. For our listeners, you might have heard Regis mentioning a couple of other episodes that we had. If you didn't listen to them, go and check them out. They are great. So Regis, thanks again for being here today. Hope to hear from you soon. Thank you guys, and see you at the next one.
Thank you very much for everything. What you are doing and what you do with those podcasts is awesome. Thank you.
Thank you.
Bye, everyone.
We would like to take the opportunity to thank Jesse de Klerk and Chris van der Kruis for all the help they gave us in starting this podcast. They have been an essential help, and we could not have kept going without them. Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on the Cisco Podcast Network in SoundCloud or your favorite podcasting app. You can also find us on our own channel called Cisco Tech Stories in every podcasting application. We are also on X at Cisco Tech Story without the S, and on Instagram and YouTube at Cisco Tech Stories. Thanks, and see you next month.
Regis walks the data floor tonight. Rack by rack, under blinking lights. Cables twist like a neon maze. He's the king of cloud highways. Packets zip through the endless stream.